I think that use of virtual reality is really fascinating. Does it offer the potential even to make projects go more quickly by getting feedback from the client more easily? Do you see potential for using it even on the job site with the construction team that's working on the project?
Hi, I'm Jeff Lee with Building Forward. I posed these questions and more on the topic of virtual reality while at the AIA conference this year. I spoke to Arlen Solacek, Associate Vice Chancellor for Capital Planning and Special Projects at Maricopa Community College, Kevin Miller, architect at GSBS Architects, and Shane Scranton, co-founder and CEO of Iris VR, discussing the evolving roles that VR plays in the building, modeling, and design process, now and in the future.
It's amazing. I mean, we've been doing this for 5 years, and when we started, VR was just getting going. And now we're into Generation 2 headsets. There's a lot more available that's pretty affordable. And we're seeing that it's really used at any point in the design and construction process where someone needs to make a decision about space. And that is many parts of the process, whether it's architects using it for design review and testing out different design iterations with the client, or the engineering team using it for coordination and understanding how all the systems are going to fit together and looking at clearances, or even construction using it for pre-construction to make decisions with the owner or actually show some of the trades on site how they're going to install something. If you haven't tried it, it's worth trying it because you can't really understand what VR does if you're looking at it on screen. You're effectively getting a left eye and a right eye, and then as you move your head around, the display's updating. So all that put together means you can really understand accurately how big a space is and how everything fits together in that space. And that's really like a natural spatial interaction that you can't get on screen. So VR unlocks that.
There's a couple of things that I've been watching. One of them certainly is augmented reality and virtual reality. On the design side, virtual reality has been like a godsend for a lot of design firms and owners because now I can get my lay users to be able to see and walk through things. We don't do a lot of hospital work, but we've seen demonstrations of being able to walk into a hospital room, being able to walk into an operating room, and have the staff really see what this is going to look like, and you make an easy change. I'm kind of getting, and you're also being able to use VR, for example, for equipment training operators. Instead of having somebody out on a front end loader, now basically it's almost like a video game where you're training them. Where I'm sort of getting excited is the augmented reality side, where you're moving this technology out literally right into the construction place. So, if you've got a tradesman who's going to put on an AR set of goggles, and instead of having to read a plan as he looks at a wall, that AR simulates where to put the stud, and he places the stud there and moves on to the next stud, and there's a lot less waste, it's a lot more effective.
Highest level goal is catch more coordination and design issues before you're on site looking at it in real life. It's a lot cheaper to change it digitally, and VR really allows you to go in and make many more decisions and catch many more errors before you're dealing with it in real life on the job site. So we see that as absolutely the highest value. If you look sort of at that ecosystem though, I think also a big piece of that is getting the owner and getting the decision makers on the same page as the professionals on the project. And VR is a really nice way to drive a lot of that understanding, because an owner might not be able to read plans effectively, they might look at a rendering and not really understand the scope of it. So by going into headset, they can participate in those decisions more effectively, and that will likely lead to fewer changes once they're on the job site asking what's been designed and what's been built.
Architecture has always been a one-off kind of a model. You design a building and then we go prototype it in the field, and all of the challenges that you encounter in that process kind of weigh it down. Do you get it exactly right in your documents, what you wanted? Is it easy to understand for the contractor so that they can build it? Is it easy so they can estimate it? And all of those kinds of things detracted from our ability to communicate that part of the project with the contractors. By the same token, communicating our vision with our clients was a challenge. You know, we had two-dimensional tools, or maybe you built a model, but your ability to communicate design intent to a client was limited to the effectiveness of those tools. And to be honest, most clients aren't all that good at reading two-dimensional drawings or understanding the language of a perspective, or even necessarily visualizing a thing that you're talking about with them. And so, you know, forever we would take them places and say, well, it'll be kind of like this. And that helped people understand what our vision was. But first with BIM and now with technologies that kind of hang off of BIM, like VR and those kinds of things, we're able to explain our ideas more clearly to our clients as well, which makes it easier to convince them that it's a good idea. It makes our work better because we understand how they're going to use the building, and we can demonstrate that understanding in a more granular way. And I think that really supports what we're trying to achieve, which is give them the best building we can for the money they're spending on it.
The way it's used today is there's desktop grade headsets that plug into a computer, and a lot of times that will be in like a conference room, or it'll be in sort of a VR demo area, and a lot of times the owner will come in and use a headset there, and then the architect or the engineer will be there as well. More recently, a lot of technology that we've been working on and that work with more headsets is the ability to host meetings even if you're remote. So if you have an architect and an owner that are in different locations, or if you have a project team that's somewhere else, they can now all put on headsets in their own location and be able to join the same model together and walk through it together, which can really reduce a lot in travel time, and also just like allow people to make more decisions in headset even if they're not in the same place.
And the way that we convinced them was the virtual reality. We said, this is what it'll be. And was it exactly what we intended in design? Oh, heck no. Very simplified, but it illustrated the difference, and it illustrated the achieving what they said they wanted to achieve in the space. And so we got through that relatively quickly, frankly, in what was a huge paradigm shift for them as a client and how they approached what they were doing.
We've seen a lot of VR setups in like the job trailer or in the job office, and we love that. A lot of times that's used by the construction team, either if they're VDC or if they're just handling the BIM files on site. They'll queue up essentially the scope of work that's going to be done by the trades that day, and in their daily stand-up, they'll put the headset on various folks on site and get them to be able to understand what's going to get built that day. I really like that application because I think it's a really effective way to communicate something that would normally be represented in plan. You can do it much more effectively just at scale, being able to look at and look around at the project. VR is getting very easy to use now. I mean, the headsets that we support are all between like $300 and $800. The computers are, about $2,000. If you need a computer, our software starts at about $1,800. So sort of the whole ecosystem now you can get set up for under $5,000, if not under $3,000. And as a result, that means that the technology side and sort of the access to the hardware and the software is really now at a point where anyone can use it. And because of that, we do see that deployment is happening at all levels of both project sizes, project scales, and industry. But yes, if you're doing a stadium, if you're doing a hospital, if you're doing oil and gas, those are very complex projects that have big teams on them trying to figure out really complex issues. We see more deployment there, but that doesn't mean that if you're a small residential architect doing small homes, there isn't value. We see a lot of value in being able to communicate design intent there, and we have single-person teams using VR as well as 10,000-person teams. And then I also think it's been really exciting to see the amount of work a lot of the larger customers of ours are doing to actually adopt new technology and modernize the technology stack. I think construction gets a bad rap and architecture gets a bad rap in its future readiness, but I think that's changed in the last 2 or 3 years, and I found it really inspiring to see how much time a lot of these customers are putting into modernizing the stack, sort of in the context of efficiency and the context of communication.
Let us know what you think by emailing me at buildingforward@hanleywood.com.